In springboot, a retry mechanism is typically configured using spring retry, a library that provides declarative retry support. Conceptually, this mechanism intercepts method calls and implements retries based on specified rules when exceptions occur. Here's a detailed breakdown of the process and what happens under the hood. #1 Proxy creation. When you enable retry functionality, Spring creates a proxy around the beans that need retry logic. This proxy intercepts method calls to the bean and determines if retry behavior should be applied based on the method's annotations or configuration. Trigger points. Retry is triggered when a method throws an exception that matches the configured criteria. These criteria are defined using annotations or configuration that specify which exceptions to retry on. Maximum number of retry attempts. Backoff policies, e.g., fixed or exponential delays between retries. 3. Retry policy. A retry policy dictates the conditions under which retries should occur. Common policies include simple retry policy, retries a fixed number of times. Exception-specific retry policy, retries only for specific exceptions. Timeout retry policy, stops retries after a certain amount of time. Under the hood, the library evaluates the exception thrown and checks it against the retry policy to decide whether to retry. 4. Backoff policy. A backoff policy determines the delay between retry attempts. Types of backoff policies include fixed backoff, uses a constant delay. Exponential backoff, increases the delay exponentially with each retry attempt. Custom backoff, allows for user-defined delay behavior. Internally, the backoff policy calculates the wait time, and Spring schedules the retry accordingly. 5. Execution and state management. Each retry attempt is managed within a retry context that tracks the number of retry attempts made so far, the exceptions encountered during each attempt. This context is updated after each attempt to ensure correct behavior, e.g., stopping after the maximum attempts. 6. Retry listeners. Retry mechanisms can use listeners to perform actions at different stages. Before a retry attempt, after a successful retry, after retries are exhausted. These listeners are invoked via callback methods registered in the retry configuration. 7. Integration with transaction management. If the retried method is part of a transactional operation, Spring ensures that transactions are appropriately rolled back or committed between retries. The retry mechanism interacts seamlessly with Spring's transaction management to maintain data consistency. 8. Thread safety. Since retriable methods might involve concurrent execution, e.g. multiple requests or tasks, the proxy and retry policies are designed to be thread-safe. Each thread's retry logic operates in isolation, preventing interference across requests. 9. Fallback logic. If retries are exhausted without success, Spring retry allows for fallback methods to handle the failure gracefully. Fallback logic is triggered after the maximum retry attempts have been reached and can provide an alternative response or recovery mechanism. Summary of what happens under the hood. Spring Boot uses dynamic proxies or AOP to intercept method calls and inject retry behavior. Policies, retry and backoff, determine the retry conditions and timing. A retry context tracks the state of the retry attempts. Listeners allow for hooks during retry execution. Integration with transactions ensures data integrity during retries. If retries fail, fallback methods or error handling mechanisms take over. This modular and declarative approach ensures that retry logic can be applied cleanly and consistently across methods or beans without manually coding repetitive retry loops. Happy coding!